In this video, I'm going to show you guys how you can solve Polynomial's equation by factoring. And this is going to be part one of a 2 or 3 part video. To start off with, I'm going to write down a learning target so you know what the focus is for this video and what you should specifically be able to know and do. So you should be able to do the following. You should be able to write a polynomial as a product of factors, so you can easily find the zeros or roots of the polynomial. Okay, so if you recall, let's kind of do a little flashback here. If you recall the following, back in chapter 1, we talked about being able to transform something like x squared plus 3x plus 2. Let's say we had this equation and we wanted to find what are the x values that make that 0, or the zeros. I showed you guys how to factor that into the product of two binomials. We did like the whole wheel technique, right, and that whole 9 yards. You know, for this one, I think the two numbers that would work to multiply to 2 and add to 3 would be just what, 1 and 2. So it would be x plus 1 and x plus 2. And the whole reason why that was great is if you know two things multiply together to make 0, that means that either factor must be 0. So we can just set each of these binomials equal to 0 and solve, and we'd get our zeros pretty quickly and easily. So these are called either the roots or the zeros of the polynomial equation. So we're going to kind of build off of that same concept today, but it's going to be a little bit more involved. So I think the biggest thing to keep in mind is the following. The first rule of factoring that you need to make sure you keep in mind is to always factor out a greatest common factor otherwise known as a GCF first. So you always want to look for this GCF first if it's there to take out. So let's take a look at an example or two where that may happen. So example 1, I want to factor and solve each equation. So we'll do 2 of them together so you hopefully get the hang of it. Let's say I have x cubed minus 8x squared plus 16x equals 0. So the first thing that you may notice is that this is a cubic polynomial because its degree is 3, and we never really learned how to factor this. And so to attack this problem, the first thing that I'm going to do is refer to my number 1 rule, is to look for a GCF. And as I scan each of these terms, I see how they each have an x in them. So I think that's all that I can pull out as an x. If I take out an x or divide out an x from each of those terms, x cubed divided by x would leave x squared. If I take an x out of the negative 8x squared, it becomes just negative 8x. And if I pull the x out of the 16x, I just have positive 16. So that's my first job. Now, I've changed this into the product of x and this trinomial, which is a quadratic, right? The degree is now 2. I can try to use some of the techniques that I've learned in the previous chapter now to factor this. Now, as I look at this, I notice that I can square root x squared to get x, and I can square root 16 to get 4, and if I multiply those together and double x times 4 is 4x, and if I double that, that's 8. That's 8x. And remember, if these terms match, if you multiply them together and double, if you get that middle term, you can call that a perfect square trinomial, and it just would factor into x minus 4, since that's a minus sign, right? We drop down the minus. It'd be x minus 4 quantity squared. Now don't forget to rewrite the GCF that you originally pulled out. So this is my new equation, and this is factored all the way. I can write this as x times x minus 4 times x minus 4 equal to 0, since it's x minus 4 squared, right? There's two factors there. So to get my zeros, I set x equal to 0, which is easy to solve. I get 0. I can set x minus 4 equal to 0, which gives me 4 if I add 4 to both sides. And if I solve x minus 4 equals to 0 again, I would also get a 4. So I get 3 zeros. 2 of them are the same. I get a 4 and a 4. When you guys do your quizzes, it'll probably list the answers something like this. It'll say like 0 and then 4 with multiplicity 2, meaning there's just 2 of them. That's like the computer's way of saying that there's 2 solutions or 2 zeros at 4. Let's do another one. Let's take a look at the following. Now this one's going to look a little unorthodox, but it's actually kind of a nice problem the way this works out. This is x cubed minus 9x equals 0. This is another great instance where you have a GCF that you can pull out of this one. So each of these terms has an x that I can pull out. So if I factor out an x, x cubed divided by x leaves x squared. If I divide 9x by x, I have just minus 9. Now, you may or may not recognize this, guys, but this is very nice. Whenever you see two terms with a subtraction sign and each of those terms is a perfect square, we're in happy land. This is a difference of two squares. I mean, I can just square root that guy and get x. I can square root that guy and get 3. And the two factors are x plus 3 and x minus 3. That's a difference of squares. Don't forget to rewrite your GCF. A lot of students forget that, and they forget one of the zeros. So here are the 3 equations I need to solve. X equals 0. That's easy. It's solved. X plus 3 equals 0. If I subtract 3, that gives me negative 3. And this one, if I set x minus 3 equal to 0 and add 3 to both sides, I get positive 3. So there are my 3 solutions. Let's see if we can kick it up a notch. Check this out. Let's call this one example 2. And what I'd like you to try on this one is just, let's do a couple of them. So I'll call this one part A. Let's say I had x cubed plus 3x squareds and then plus 5x plus 15. And I want to factor and solve just like before. So I'm factoring and I'm solving. Now you look at that and a couple things might enter your mind. Number one, if you've been paying attention, you might already be looking for a GCF to factor out of each of these. And it's tempting to pull an x out, but this guy, I can't pull out an x. It's just 15, so there's not a GCF of x, and I can't pull out a 5 out of everything. There is no GCF. So I'm stuck there. The other thing you might notice is that there are 4 terms here, right? This is the first, second, third, and fourth. If you see 4 terms, you have to do something called factor by grouping. And actually, factoring by grouping can be kind of fun and easy, especially because the dead giveaway is that it's got to be 4 terms. Anytime you have 4 terms, you're going to go to factor by grouping, this following method. So let's talk about the steps and make sure you keep these steps kind of handy when you practice some problems. So if you get stuck, you know what to do. So here are some steps, okay? If you see 4 terms and you want to do this factoring by grouping thing. First, what you want to do is you're going to pair up the first 2 terms and last two terms with parentheses, right? So what I mean by that is this. If I did that in this problem, let me get rid of a little bit of my scratch there. If I did that here, here are my first two terms. I'm going to put parentheses around those, and then I'm going to put parentheses around my last two terms. That's your first move. You should always set parentheses around the first pair and the last pair. Okay? After you have that done, this is the critical kind of grouping step. What you're going to do is factor out the GCF from each pair. So what that looks like here is the following. Let me rewrite my equation, okay? So if I do that, I have, let me see, I have x cubed plus 3x squared in parentheses, right? Plus, we had 5x plus 15, and this is all equal to 0. So if I do that, guys, the GCF of x cubed and 3x squared, I think you would agree, I can pull 2 x's out of x cubed, and I can still pull 2 x's out of the 3x squared. So I'm going to factor out from here an x squared, and if I take x squared out of the x cubed, I'm left with just 1x. And if I take the x squared out of the 3x, I'm left with just plus 3. Always get in the habit of, in your head at minimum, and I wouldn't maybe like extra, in your head, redistribute that and make sure you get back to the original. So I know x squared times x is x cubed, x squared times 3 is 3x squared. So far, I know I'm in good shape. Out of the second pair, I think you would agree I can divide out a 5 from each of those. So over here, I'm going to write plus 5. And if I divide 5x by 5, I'm left with just x. If I divide 15 by 5, I'm left with just plus 3. Now check this out. This is the important thing, and I'm going to write this down in our yellow as our third step. You should notice the binomial in your parentheses should match. So they should match. If not, you might have goofed and you have to like double check how you factored out the GCF, or it's just not factorable and you have to stop at this point. Okay, so they should match. And so what I mean by that is this: as you look at these two binomials, this guy and this guy match. So what you're going to do for your fourth step is the following. So step 4, you're going to factor out the matching binomial. And this is what I suggest you do. I suggest you can either box the matching binomials, and then you're going to rewrite them separately. So x plus 3 was the binomial. And then what I suggest you do is maybe circle the numbers that you pulled out in front. In this case, it's the x squared, right, and the positive 5. Put those two terms together in another set of parentheses, like so. So I put the x squared plus 5 together, and guess what? This thing is factored. I now have it written as the product of x plus 3 times x squared plus 5. And you're all done. Just this one time, let's kind of check, just so you might be thinking, there's no way that what we did worked. If you check by multiplying this out and do x times x squared, you get your x cubed. Then x times 5 is 5x. 3 times x squared is positive 3x squared. 3 times 5 is positive 15. If I reorder these, this is the original problem that we started with, isn't it? So it actually, that's a 15, this actually worked. So at the end of the day here, what we can do is try to find the zeros. We're going to set x plus 3 equal to 0, which means negative 3 as a solution. Then we can set x squared plus 5 equal to 0, and you have to apply what we learned last chapter. This is a quadratic. I'm going to get the x squared by itself by subtracting 5 from both sides. So I have x squared equals negative 5. Now I'm going to square root, and I remember it's plus or minus the square root of negative 5. And if I have a negative, I poke an I out. So my other two solutions are plus or minus I rad 5. There are all my solutions. Actually, if I write them out, there's a negative 3, a positive I root 5, and a negative I root 5. So I still have 1, 2, 3 solutions in all. Now that might seem overwhelming, but that was also because I took a great time in explaining it in detail. I'm going to do one more with you to kind of get you in the hang of it, and then we'll probably end the video with this next one. Okay, let's call this example 2 part B. Let's write x cubed minus 3x squared minus 5x plus 15 equals 0. Okay, so this is the first thing you should do. As you look at this, guys, is there a GCF? And as you scan, you should see, nope, there is no GCF. I can't factor anything out. Now, I do notice that there's 1, 2, 3, 4 terms, so I know I'm going to group this thing, right? So I'm going to pair this up, but now check this out. A very, very important symbol is right there. If your third term is negative, so if your third term is negative, put your parentheses around the negative. So what I mean by that is this. If it's negative there, when I make my parentheses, I'm going to put my parentheses around the outside of the negative, and you're going to see why in a second. When I do my second step of pulling out the GCF of the first pair, that would be an x squared. And if I divide out the x squared, I'd be left with x minus 3. Now, when I move on to this binomial, I'm going to always make sure to factor out a negative term if that third term is negative. So the other thing to keep in mind is factor out a negative GCF. If you don't, you'll notice it's not going to work. So here, I notice I can factor out a 5 from both of these terms, but instead of pulling out a positive 5, I'm going to pull out a negative 5. That is key. If I take out a negative 5, negative 5x divided by negative 5 leaves positive x, and if you divide positive 15 by negative 5, you get negative 3, right? Negative 5 times x, negative 5x, negative 5 times negative 3 is positive 15. So we've done that correctly. Now check this out. The x minus 3's match, don't they? So we're going to rewrite x minus 3, and then I have an x squared minus 5 that goes in another set of parentheses. Remember, this is all equal to 0. So I'm almost done. I set x minus 3 equal to 0, which if I add 3 gives me positive 3 as a solution. And if I set x squared minus 5 equal to 0, I add 5 to both sides, and I get x squared equals 5. And now I can square root, and don't forget plus minus. It's either plus or minus the square root of 5. No I to poke out on this one. So my solutions are 3, positive root 5, and negative root 5 for this polynomial. I think I have to show you one more thing. I know it's a long video. Example 3, I think I got to show you one thing though so you don't kind of stumble on this one, but I bet if I write it down, those of you guys who are kind of looking closely would know what you would need to do first on this one. So as you look at this, you might say, hey, there's 1, 2, 3, 4 terms you're going to group, and you would be right, but you want to do something first. If you look carefully, each one of these 4 terms has something in common. We can factor out an x. If I take out that GCF of an x, I'm going to be left with x cubed minus x squared. This becomes minus 4x, and the 4x became, or will become, just positive 4. Now, I have this as x times this thing. There's still 4 terms, so I still need to group. Let's just do one more together anyway, since it might be a little tricky the first time you do this. So if you group this, you pair up the first 2, and oop, check it out, I got a negative here. I'm going to put parentheses around the negative so I don't goof up my grouping. Now check this out. For this step, what I'm going to do is copy down my x, and now the GCF for this pair is x squared. Let me put brackets here for those sets of parentheses. When I pull out an x squared, I'm going to be left with x minus 1, right? If I divide out x squared from x cubed, I get x. Divide x squared by x squared, I get negative 1. Now out of this one, because this is a negative, I'm going to put out a negative GCF, and I think that's going to be a negative 4. Negative 4x divided by negative 4 will leave positive x. 4 divided by negative 4 is minus 1. Now check this out. These match, so that means I can pull it out and write x minus 1, and then I put x squared minus 4 together in another set of parentheses. Now don't forget, this is all set equal to 0, and also don't forget about your GCF that's there. Now, ooh, check this out. I have x minus 1. X squared minus 4 is a difference of squares. Can't I factor that into x plus 2 and x minus 2? So I'm going to take it one step further. I have an x minus 1 and an x plus 2, x minus 2. I can set each of these factors equal to 0. If I set x equal to 0, I get 0. If I set this one equal to 0, I get 1. If I set this guy equal to 0, I get negative 2. And if I set this guy equal to 0, I get positive 2. So I get 1, 2, 3, 4 solutions in this one. Guys, thank you for watching. I hope that this will help you, and good luck on your video check.